one of the reasons that I miss going to NI Week, and I don't go anymore because National Instruments has kind of changed, not really changed directions, but they basically don't do industrial automation, the type of stuff I do anymore. But the subtitle, no matter what the title of their event always was, the subtitle was always solving big problems. They were always talking about that, solving big problems. And that stuck to me because that's what engineers do. Engineers solve problems. And solving big problems requires a lot of talent, a lot of technology, creativity, and so on. And I'm going to morph from, and I actually didn't come here to talk about National Instruments. I came here to talk about solving big problems. This is Gary Minchell. This is Gary on manufacturing. And thanks for listening. And this podcast, as always, is brought to you by my sponsor, Inductive Automation. Discover a whole new view with Ignition 8 by Inductive Automation, packed with features for the modern control system like unlimited licensing, high-powered tags, mobile first flexible design environments for all devices. Ignition 8 supports enterprises of any size. See all Ignition has to offer at inductiveautomation.com. Obviously been too long since I've done a podcast. The last one I did was a conversation that was actually video recorded as well as audio recorded by another company, which I published. So anyway, I was thinking about solving big problems when something spurred me to think about the creation of the original Programmable Logic Controller, the PLC, and did a little bit of research and listened to an interview with Dick Morley. And in my travels over the last 20 years, I've had the pleasure of spending quite a bit of time at off and on with Dick Morley and listening to his stories and and the way he looked at technology and trends and so on. You know, it was really interesting. So to talk about PLCs, I wondered, well, what problem were they trying to solve? I'd heard the story, I knew what Dick was doing and so on, but it turns out that General Motors had a problem. And the problem was they had these machines. The machines were controlled by banks of relays that were all hardwired together. And usually what would happen is one relay would trip, and then that would trip another, you know, the contact would go and would work with another contact and so on. And since it was all wired and soldered and everything together, it was really hard to change. And so every year at model change time, and back in this is 1968, and they had a model change every year. When I was a kid, I used to love to go to a friend of mine's house whose dad worked for the local Chevrolet dealership, and we would go in and he would get a car a week ahead of time, and it'd be under wraps, and in his barn it was delivered at like 2 in the morning, so nobody could see it, and we'd get the first look at the new Chevys at the time. But at any rate, they had the annual model change, but it took forever to change all those relay banks and rewire and everything to get the machine set up for the new model year run. And they just couldn't take that anymore. They needed a better, faster way to make these model year changes. And they went out for a quote, and they contacted, one way or another, Dick Morley got involved with a group that he had in New England. And Dick was a MIT engineer, and had a bunch of friends. And they also went to a company called Allen Bradley, and Otto Struger was the vice president of technology at Allen Bradley at the time. And those two, Otto Struger and his team, Dick Morley and his team, proceeded to find a way to solve that problem. And Dick says that Allen Bradley won the spec war, and the spec was written around Alan Bradley's approach, which was taking their existing um, uh, relay banks and wiring them and putting some programming on those. Dick took a slightly different approach and with some programmable stuff, but at either rate, it turned out that they both came up with a way to program, as in software, the relays to make it easier to change over. And I think Dick said they had 4 relays. You only needed 3 for the number of decimals that they needed and everything, but they did a 4th one for the heck of it. And whatever. At any rate, by 1968, 2 things were born. One, the PLC was born, which helped solve GM's immediate problem. And the other thing that was born was a company that then got formed by Dick Morley called Modicon and Alan Bradley. And the competition between Alan Bradley and Modicon lasted for a long time. When I started selling Alan Bradley equipment, PLCs, and so on in the 90s, my biggest competitor was still Modicon in the United States. Now, many other companies had actually come and gone by that time, but the competition between Alan Bradley and Modicon was great for technology development. It was great for the end users because they had a continual cycle of upgrades. I never knew the Modicon numbers that well, but you could cycle through the PLC2 and the PLC3 and the PLC5 from Rockwell, and I was selling PLC5s, which is the big iron, and then they came out with the SLC, which probably meant small logic controller, the SLC 500, and then we started down the path of smaller, better, faster, cheaper programmable controllers, and there's been a whole evolution since then of innovation in machine control, and it solved the original big problem, and the problem just stayed. I mean, every time they got better, they wanted more. GM would need more, faster. I need a faster changeover. I need to be able to do this and this, and if the truth be known, it was the customers who drove the product innovation and product development. The technology supplier engineers would go visit, and the end users would say, "This is what I need this, this, and this," and they go back and develop it in the labs, and so on. And they're solving these engineering problems. I got to thinking about all this because of the idea of digital transformation that is on everybody's minds these days. We're all talking digital transformation, and they're talking like that's like a 2-year-old phenomenon. And I went, it's not a 2-year-old phenomenon. We could easily, in our industry, in manufacturing, and also process control, which about the same time they were starting to look at digital ways of doing their banks of manual control valves and so on. And it was all digital, and they were doing it as far back as 50, 52 years ago. We started on this track or this path that we're taking. So then we add things. So on the other side, on the manufacturing management side, we started out with things called material requirements planning, which they started adding modules to that. And when I came along, I was implementing something called MRP 2. Oh yeah, what was it? What would we program that in? Anyway, it doesn't matter. So we're digitizing inventory control, routings, job costings, bill of material costing, all that sort of stuff. We started to digitize, and the project I worked on dates to 1978, and that was all existing software I bought from IBM, and that was all existing, and I went to IBM school and all that kind of stuff to learn how to do that. And so we're digitizing on the manufacturing management side, and we're digitizing on the control side, and we're still working on these sort of in tandem, but they just keep coming together. As a matter of fact, on the control side, there's a there's an ongoing project started just a few years ago by ExxonMobil trying to solve a problem, and it's called the Open Process Automation Forum, and the OPAF for short. And they have a number of people from all different segments of the industry that are looking for ways to do for the DCS, to bring it up into this realm of a software-defined controller where I can upgrade without having to rip out any hardware, and I can keep up with the latest technologies that I need for better control, but at the same time keeping my cost of changeover down, which was that same thing of how can I keep the cost of changeover down, and how can I change over much more quickly than I've done before. So we've got from the PLC to OPAF, from MRP to MRP2 to what we call MES. MES got renamed from Manufacturing Execution System to Manufacturing Enterprise Solution or something like that. But now we have the Internet of Things, which basically just adds in a way that, we had a little bit of data that we could gather from the PLC and the I/O modules, the data table, and so on. And well, what if we tapped into more data from all these sensors, and we could accumulate that data into something, not only OSI Pi, the historian, but into other kinds of databases, and then start doing analytics on top of that, and feeding back information to operations management and maintenance and reliability management, and even into business management, and feeding into the ERP systems that had come along. And now we have a whole ecosystem of digitization that's all going together, and it's all coming together. So we have IoT, we have all the better control systems that are all switched to digital and just keep advancing. And then on the software side, we've gone from just an MES, just an execution system, to execution plus analytics plus visualization, which gives us a better digital overview, which links into things like augmented reality, where maintenance and engineering people can put on glasses and see part of the situation, and see overlays of information with coming right out of the control, right out of the design and everything. This is all digital transformation. We're managing our manufacturing and our production, and all from upstream, downstream, in oil and gas and petrochemicals to discrete manufacturing, food and beverage, which is a mix of process to mix stuff up, and discrete manufacturing to package and so on, and other pieces of the process. And that's a bit of a trail of digital transformation, and every step of the way management gets better. And now they talk about transforming our businesses. Well, God, we've been doing that for a long time, and we're still working on that. And it's going to be a never-ending thing. Just like lean is a journey, not a destination, and it keeps us on the way. Digital transformation is a journey, not a destination. And we could trace it, I think, we could trace it back to Otto Struger and Dick Morley competing over a General Motors contract for how can I automate or program my relays. We've gone a long way since then. It's really cool. And speaking of, how cool on the software side, the HMI SCADA, which has blossomed into some of this analytics and stuff, and that leads to my sponsor. So the podcast is brought to you with the support from Inductive Automation. Discover a whole new view with Ignition 8 by Inductive Automation, packed with features for the modern control system like unlimited licensing, high-powered tags, a mobile-first flexible design environment for all devices. Ignition 8 supports enterprises of any size. See all that it has to offer at inductiveautomation.com. This is Gary Minchell, Gary on Manufacturing. Thanks for listening.